Hello, we are Metaphora Delivery Systems. This is our proposal for the delivery spacecraft capable of carrying up to 120 tons of payload and 6 astronauts to Martian orbit in 256 days. The ship will then be idle in orbit for 445 days before returning to Earth for a total trip time of 965 days. To allow this mission time to be carried forwards, a simple train of delivery probes with manoeuvring capabilities will be sent to Mars orbit a few months before the mission. This will contain the resources needed for the stay in orbit and the return mission to Earth. This reduces the energy requirements from the engine. This infrastructure can then be implemented and extended in future missions as a means of transporting scientific research equipment and life supplies for future settlements on Mars.
The ship will consist of a habitat module in the centre, 4 nuclear thermal rocket engines at the rear, their hydrogen tanks, and a resource module at the front where water, oxygen and foods will be stored. All the walls of the spacecraft will be constructed out of a wall made up of carbon nanotubes for structural rigidity and lightness, aerogel for high degree of insulation, and titanium and aluminum alloy for radiation protection.
The first stage will be based on the RS-25, which produces very high thrust whilst maintaining an impressive specific impulse. This allows the ship to be accelerated to the desired velocity in less time. 4 other engines will power stage 2 and above, which works by heating hydrogen through a uranium fission reactor, thus expanding it through a nozzle at very high velocity to produce thrust. This gives a specific impulse twice that of the RS-25, which means we can pack much less fuel and so be capable of a lower burning time.
Instead of reclaiming oxygen, we will simply take the needed volume of it for the whole duration of the mission. A container of 3.6 meters cubed in the resource module will store it in liquid state for easier storage. The oxygen will be taken through a heating mechanism, bringing it back up to room temperature and allow it to flow into the living areas at 2.1 litres per minute. A positive system will be used to keep CO2 levels correct. It uses silica gel and zeolite to remove the gas from the air, which can then be disposed of.
The diet for the crew will consist only of dry food later rehydrated. We have chosen this as it's the most space and weight efficient method. Here are some of the items we will use to meet the dietary requirements. The total mass of the food for the first leg of the journey will be 2.8 tonnes.
A reverse osmosis system will be used to replenish the water supply. This uses high pressure to allow only water molecules to move across the membrane, thus filtering the water. The system will be very compact, light, and is 90% efficient. Day to day, the crew will need a total of 21 litres per day to drink and to rehydrate the food. To start the reverse osmosis process, we will need to take up 2.1 litres of water per day to compensate for the 10% loss. The total amount of water for the first leg of the mission will be 600 litres.
Zero gravity environments can be detrimental to the crew health. A gym will keep crew members busy as well as compensating for any muscular strength loss. The crew will also be able to communicate using existing satellites with loved ones on Earth. A medical bay will be capable of treating minor injuries.
A docking port on the habitat module will dock the spacecraft's ISS docking port using current KERS and IBDM docking systems. When docking to the resupply probes, the payload module will unlock from the resource module. A port at the front will dock to the extra fuel tanks with capabilities to transport the fuel to the engines at the back. Seeing as this is the first trip of its kind, the crew's safety is important. The astronauts need not leave the spacecraft as drones will take care of any external repairs. The ship will also have solar panels at the back for backup power so that important systems can be kept functioning in the event of a power down.